Let me talk about internet protocol. These are the rules that governs communication within the internet. And the transmission control protocols and internet protocol is a protocol at the heart of our internet. As we can see here, we have a lot of channels, transmission lines. So we need rules to govern how the data is transmitted through and how data is protected within the internet from host 1 to host 2 or any different computers connected to the internet. Okay, so let me talk about HTTP, which is a web language, and what it does, this protocol, it just fetches web pages, images and data over the internet using reliable TCP connection, and you can use it when browsing through websites, accessing web application, API calls, and downloading some contents. You can see, but HTTP is hypertext transfer protocol. It's not secured because it doesn't have the encryption connection, so it doesn't have the encryption key. As you can see, it's difference between HTTP and HTTPS. HTTPS has encrypted connection, which means the transfer is protected by an encryption key. However, the HTTP is not connected. It is not secured, of course. So daily examples, we can talk about everyday searches whenever through whatsoever browser you're using. So all the searches use HTTP and HTTPS, of course, which is the beta version of the HTTP to send web requests or HTTP requests over servers, web servers. You can see here, you can just browse requests, you send the HTTP request, and this is how it is. It is how it works. The server just processes and the connection and then send back a response to the host who's trying to access the internet. And we go through TCP and UDP. So talking about TCP, we know TCP is very reliable, but it's kind of not that fast. However, UDP is fast, but not reliable. So the connection through TCP, it's connection-oriented protocol which ensures the arrival of intake in the correct order. So the data arrives in the order it was transmitted. So if you send an email or you browse through the web, you do some banking transactions, so usually they use TCP. But for the UDP, it's just connectionless protocol that prioritizes speed over the guarantee of delivery, which means some packets might not be delivered or might be altered along the way, but UDP maybe does not care, but it's only concerned about the speed. So that's why it can be used in live video calls, because basically it's continuous communication and we need fast speed so that the communication syncs well way from the one end to the other end in real time, so it can be faster. It needs to be faster, so that's why I use UDP for live streaming and also DNS queries. You can see here how what do I mean by connection oriented. TCP uses the so-called handshake protocol, and then UDP just use datagrams. The handshake here is called three-way handshake. When you do networking, you can learn this. We will learn this, of course, maybe in the future classes. I know where how the three-way handshake really works when you transmit data using TCP. And UDP, of course, does not use handshake. It's just data flowing through. Requests go straight to the server and coming back As you can see, for the UDP, the request just go back to the server. It's just one way, request, response. And then for the TCP, is basically you have to send the COIN, and then the receiver has to send back an acknowledgement of the COIN, and then so the server after all will acknowledge the connection over the internet. So talking about IP and IPX, this is basically addressing the network. How do you address the network? So it's the root, the internet protocol is the root, which is the universal addressing system that enables packet routing across global internet, and every device needed an IP. So to connect or communicate over the internet, you need to have an IP address. And maybe using a smartphone or computer, you still need an IP address, and that will help you connect, or that will be your identity over the internet. And the IPX is just Internet Packet Exchange Protocol, which is primarily used in all the novels network, which means it's an older version of IP. Now it's not used, of course, by most connections or computers. And when is it exactly used? We can say large enterprises network that have been migrated to IPs, that the old companies maybe might be still using this. And of course, so what happens here? How do IP really works? So we have the source host, which just have the IP, which sends information. So we just recognize the host, the source host, by its IP address, and along the way, the IP header is created, and which means the data is kind of encrypted, getting encrypted each and every way it passes through the channels or the transmission channels, and at the end it has to be decrypted so that the receiver will receive the data that was originally sent from the host. And the universal plug and play is basically used in discovery. So we use UPnP for discovery, and we use DNS for just naming. And the UPnP it's auto, so it's automatic, and it's a universal plug and play that which enables devices to find and configure each other automatically on local networks. Daily use in smart TV, finding media server and printers appearing automatically. Some gaming consoles connection to routers, they basically use the UPnP. The DNS just naming, so it's the domain name system that translates human readable website name. So let's say google.com or myhome.com, or anything that has to do with a web page or something. So because the web page is just a string which the computer might not understand, so the DNS interprets or translate that into an IP address, or an address that can be understood by the computer. So that's the work of the DNS. As you can see here, just the host name, you type search google.com. In order to get into google.com, the DNS will help you resolve or like translate that google.com you typed into anything, maybe like the address of google.com, corresponding address for google.com, and then you will get to access google.com, and then you get the response, then you can browse and connect. We go through the DHCP and ICMP. So these ones, I group them together because they are both used for network management, And the DHCP, which stands for Dynamic Host Configuration Protocol, which it automatically assigns IP addresses, submasks, and gateway information to devices joining the network. So what happens here, the home Wi-Fi networks, corporation LA and LANs, local area networks, public hotspots, these ones they use the DHCP. So the IP address are automatically configured. And the ICMP network, the ICMP just for the network diagnosis. So it just diagnoses the network. Is it safe or not? So it's an internet control message protocol, which is used for error reporting and network troubleshooting tools like ping and trace routes. So it's basically controlling errors. So if there's an error, so you type wrong, then it will pop up error message. So that's the work of the ICMP, the Internet Control Message Protocol. What happens here, if you can see, you just send the DHCP request, and then the DHCP request will just assign the IP. And then it sends the ICMP ping, which will check for errors in the connection. If there is no error, then you receive an accepted connection accepted. That's what happened. Then for FTP and POP, no, triple POE, I can say, is just these ones. The FTP is file transfer protocol for file transferring, and the PPPoE just it's called broadband. What happens here, when you want to transfer files, you need a rule to transfer the file. So the file transfer protocol enables uploading and downloading, or downloading files between clients and servers. So maybe the file is stored in the server, so you want to access it through the web or something, or any software, you want to access that. So for you to get, you need to have the authorization, which comes with the access of file transfer protocol. And then for software distribution and backup systems, you also need transfer protocols, so that because you're accessing files which are saved in a server, and you want to use them in your own PC or your own computer, so you need authorization to that. So the file transfer protocol is the rule that enables you to do that. And let's talk about the PPPoE. Okay, here is how the file transfer protocol works. It's just FTP host stores the files, and then the client just log into the host, and then the client programs to get a file, and then FTP host downloads the file with errors or without errors, depending on whether you have authority to get that file. You are authorized to download that file or not. And this is how it happens. Then the triple POE, I can say, is just for the DSL connection. It's a point-to-point protocol over the internet encapsulation. And this one, the PPP, the triple P are just frames for the DSL breadboard internet, and over the internet encapsulation. What happens here? The DSL Internet Service, ISP authentication and session management, they are all controlled. They are connecting to this. You're all controlled by the PPPoE. So this is how it happens here. You are transferring the file. When transferring the file, you need to use the file transfer protocol to connect. Clients can connect to the FTP server. And then the triple POE session, what it does, it authenticate and establish a link, so you can be able to download the file. And then once the link is discovered, and the ISP access, the ISP you're using is verified, then now you can download the file. NAT, that's called NET, and SMTP. The NAT just do translation, while the SMTP is just for emails, of course. So what happens here, the network addressing translation, which is the NET, it allows multiple devices to share a single public IP address for internet access. Maybe you have computer A and computer B. They want to connect to the same server, so then it will allow them to connect using the same IP. And what happens here, maybe this one essentially, maybe in your home or your house or your apartment, you are using the same router just to manage dozens of connection with the ISP provider. Uh, the, then you can use the NAT to translate the addresses. And what happened to the SMTP? Just for email delivery, to ensure, let's say you're trying to send an email to the whole school or to help students in the school. What happens here, you need simple mail transfer protocol. This one is just for simple. It handles sending emails message from clients to the mail server and between servers. Every time you hit send, the email, the SMTP, it just carries your message to the recipient, which is the recipient mail server. You can see how it works here. You are sending a message, the sender just send a message, and the SMTP carries the file through the mail mail server, and then it goes through the internet, and once it is received over the internet, and then with the POP3 and IMAP, what happens, this one just maps directly to the correct address we were sending the email to from the receiver's mail server. So this is, of course, for maybe for private emails, we can look how the NAT and SMTP flows. When the recipient mail server, destination server, okay, we start with the private email client, just a device behind the net, which is the one writing the email. And when this one sends the email, the NAT just translate the IP address and map it into public address. So we don't want the private address, IP address, to be known in the over the internet. So what happens is we just generate a random public IP address, and then the outbound, the relay here by the SMTP, or through connection, or of course by with relevant to the ISP and the mail server accepting the mail, if it's authentic or the number you're sending to is correct or the email you're sending to is good. So what happens here, the internet delivery, it just routes via the public to the recipient server, and then the recipient mail server, which is the destination, just accepts the message. That's how the email is successfully sent. So the complete protocol stake, in conclusion, to understand how these protocols and standard works, it's really crucial, because all these layers works together seamlessly, because it's invisible, it's digitalized, it's digital. We cannot see, we just send, click send, we use icons. Maybe we need to understand how exactly these files are transferred, or this message is sent from one host to another, or from host to server, or from server to client, how exactly it happens. So this is the layers. We have the application at hand. I can say Gmail, for sending like mails. And then what happens here, we also have the web with Chrome or Firefox. What happens here, you just have the HTTP and FTP, and these protocols, the DNS, of course, to translate the name into IP. We need them first in the top layer, because this is where you you start. The first action is to access the web. When you access the web, you need to have the IP address, which is of course by the DNS, to translate your search into the corresponding IP address for that web. And then to transport layer, now you already made the message or the mail you want to send, or your message to the server. We need the TCP. We need to know which protocol you're using to send the message. If you want to send maybe packets of videos, like I said, for TCP is used for is used for like a secured connection, and TCP is a little bit slow, because what happens here, we send packets and they are being received in the same order they are being sent, while UDP, the packets are just sent, don't care what if they will receive everything or not. So it, which leads to faster transfer of the message sent, of course. For video, for streaming and stuff, we use UDP. So that's the layer where you need to transport the message. So that's the channel. And then we need the network layer to connect now to the server. To connect to the server now, we need the IP. Use the IP. So we are being identified by the server through your IP, and the ICMP and IPX. IPX for the older version, of course. But that's basically how the message is being channeled, how you the host, I mean the host or the client connects to the server. And then once you're being connected to the server, we need the internet, and we need Wi-Fi, where of course to access that, the base of everything is you need to have data bandwidth to connect through the Wi-Fi. So maybe you can search and then it tells you connection failed because you don't have Wi-Fi or internet. So that's it basically for the internet protocols. And I hope, oh, not I hope, why this protocol matters. I already explained why they matters. For connectivity, we need to understand them so we can be able to optimize. How can you optimize? So it's our duty as student to learn how to optimize the available network protocols or connection, and improve from the issues that already exist, maybe for security measures and stuff. And for the connection, we need to understand how browsing and streaming on all the emails and smart devices communication really work, the internet of things. How do you send data? Because sometimes you say, okay, you call your friend, I'm calling my friend, hello, hello, hello. I don't really understand how the message is being transferred from me in real time to my friend, and then my friend respond in real time to me, and we all communicate effectively. So sometimes, due to network problems, maybe there is some stunt, or like we cannot hear each other really well because the next connection is being cut out. So we need to improve from that. So for future evaluation, we need to understand this kind of protocol so we can be able to come up with maybe improvements, security measures, of course, new ideas. Thank you for your time. I rest my